Hey guys, this is Coach Lowe, and yes, I know I sound different because I have lost my voice pretty much. So yeah, but we're going to go ahead with this. We're starting chapter 6. 6.1 is angles of polygons, so we'll do the best we can with communication. Sorry, I'm not going to do cue cards. All right, or subtitles. Find the sum of the measures of interior angles of a convex polygon. So let's let's see if we can figure out some of this terminology before we get started. First of all, polygon. A polygon is a figure that has edges like straight sides and they're all connected and they're not ever going to cross. So you guys have worked with these quite a bit. You've worked with quadrilaterals, four-sided figures, um, hexagons, six-sided, pentagons, five-sided. So there's a polygon. It has five vertices, five sides. And then we can also talk about diagonals. So I'm just going to go ahead and draw these two diagonals. Diagonals come from a vertex and go to another vertex that's not right next to it, not adjacent to it. But notice that I have three triangles. I know the degrees in these triangles all add to be 180 degrees. So if I have three triangles, then I have 540 degrees in this pentagon. A regular pentagon, the sum of the interior angles will be 300 or 540. Now there's a kind of cool pattern to this. We go ahead and draw a hexagon. 4, 5, 6. All right, so I'm going to go ahead and draw diagonals from this vertex. And you see there are four triangles, six sides, four triangles, five sides, three triangles. Interesting, difference of two, right? That's actually the formula to be able to find the sum of the interior angles. The formula says that if I add all of the angles up in this hexagon, so these angles here, or in this pentagon, that it's the number of sides minus 2 multiplied by 180 degrees, and that will give me the sum of the interior angles, which is exactly what happens when we draw triangles. Five-sided figure, we get three triangles. Six-sided figure, we get four triangles. So for an n-gon, which means any number of sides, I can use this formula n minus 2 times 180 to find the sum of the interior angles. All right, there's a list of these types of polygons from 3 sides to 12 sides. Then after that, we usually call them n-gons, but it is on page 390 in your book. I almost put degrees on that. That's funny. So page 390 in your book. All right, so a nonagon. A nonagon has 9 sides. So if I want to find the sum of the measures of the interior angles, I do 9 minus 2 times 180. So that's 7 times 180, and 7 times 180 is 1260. So 1260 degrees on the interior. So if I draw 9 sides on the inside of the triangle. All right, so I'm pretty sure you could do the rest of these. Heptagon, we'd have 7 minus 2 times 180. If you want to pause the video and try these, go right ahead. Decagon, 10 sides. 10 minus 2 times 180. All right. So 5 times 180 is 900. And 8 times 180 degrees is 1,440. All right, let's skip to the next one. The measure of an interior angle of a regular polygon is given. Find the number of sides. All right, so we know the sum looks like this. And we don't know how many sides there are, but we know each angle measures 180. So we know, 108. So we know that this is equal to 108 times the number of sides. Remember, n represents the number of sides. So 108 multiplied by the number of sides is equal to n minus 2 times 180. So 108n equals little distributive property here. 180n minus 360. Fun times with solving equations. Subtract 180n from both sides. We want our n's together on one side. And when I subtract that, I get negative 72n. This is gone. Equals negative 360. Last step to solve this, divide by negative 72. And n is 5. So the number of sides in that polygon is 5. All right, let's go to number 5. It's the same setup on all of these. We know that the sum of the interior angles will be 120 multiplied by however many sides there are. We also know the formula, number of sides minus 2 times 180. All right, so solving this one, 120n equals 180n minus 360. Subtracting 180n from both sides, I get negative 60n equals negative 360. Divide by negative 60, and n is 6. So hexagon on that. Hexagon on that one. Pentagon on the first one. All right, let's go to the next. All right, find the measure of each interior angle. All right, so first of all, let's see how many sides there are. 4 sides. So I know the sum of the interior angles is 4 minus 2 times 180. All right, so that's that n minus 2 times 180. So I want to find how much they total before I start. So any quadrilateral, any 4-sided figure, the sum of the interior angles is going to be 360 degrees. So for number 7, 2x minus 15 plus 2x minus 15 plus x. Now, you could have just said 2 times this since they're the same, and 2 times that since they're the same, equals 360. Putting all of my x's together, 2x, x, and x makes 6x. And I have 2 minus 15s or negative 15s if I change to plus and negative, so minus 30 equals 360. Adding 30 to both sides to solve this, 6x equals 390. And then I'm going to divide by 6, and so 65. All right, so if x is 65, I know angle D is 65, angle B is 65, angle A is 2 times 65 minus 15. 2 times 65 is 130. 130 minus 15 is 115, and angle C is the same. All right, hope that makes sense. Okay. The bottom, number 10, let's try this one. These, we would do the exact same thing, set it equal to 360 because both of these have 4 sides. They're both quadrilaterals. Trapezoid, or both trapezoids actually. Number 10 has 6 sides. This vertex is H and that one is G. So if I have 6 sides, I want n minus 2 times 180 to find the sum, which would be 6 minus 2 times 180 since it's a hexagon. And 4 times 180 is 540. What? Stop. That's not true. 4 times 180 is 720. I don't know where 540 came from. I have no idea. I just made it up. All right. I'm going to try not to make up things today. Well, maybe. All right. So let's solve this for x now. So notice I have 4 7x's, which would make 28x, because 7 times 4 is 28. And then I have 2 4's, which would be 8x. Now you don't have to do that. You can line them all up and go 7x plus 7x plus 7x plus 7x, but we know that's 28. And 4 is 8. All right, so this makes 32x equals 7. My goodness, how about 36? 36x equals 720. So x is 20 when I divide 36 from both sides right here. All right, now notice these were on the same side, so I just mushed them together. So you just add those. All right, so x is 20. Now I go back and plug in here. So angle D is 7 times 20, which would be 140. So is angle E, angle H, and angle G. They're all 140. Angle I is 4 times 20 or 80, and so is angle F. All right. Find the measures of each interior angle of a regular polygon. Well, we can definitely do that now. Hold on, TV timeout. You can take a dance break if you want to. Just do a little math dance. Do the math dance. Do the math dance. Do the math dance. Do the math. Okay. All right, enough break. All right, so finding the measures of each interior angle. We've done this already, right? N minus 2 times 180. That gives me the measure of the interior angle. So you just need to recognize how many sides. So 4 sides on the quadrilateral. Sorry, I skipped to 12 already. 4 sides on the quadrilateral. 5 sides on the pentagon. 12 sides on the dodecagon. Plug into the formula, run with it. All right, find the measures of each exterior angle of a regular polygon. So exterior angles of a regular polygon. So that means, let's say that we have a pentagon. Exterior angles would be when I extend these lines out here. Exterior angles. So 1, 2, 3, 4, 5. Those angles will add to be 360. And it doesn't matter how many sides the figure has. Exterior angles add to be 360. Interior angles, we think about diagonals and adding triangles together, and there's always going to be 2 less than however many sides there are. So interior angles, we have that little formula, but you can just remember number of sides minus 2 because we draw triangles, and then multiply that by 180. Exterior angles of a regular polygon, add them all up, set it equal to 180. Set it equal to 360. All right, so let's say that we have a figure. Well, let's look at these first, I guess. So an octagon, just a regular octagon means all of the exterior angles would be the same. So that means I would have 8 exterior angles equal to 360. So x equals 360 divided by 8, which is 45 degrees. All right, so this would be 9x equals 360. So x would be 40 degrees, and so on. All right, so last one. All right, so let me extend these out here. Oh, yeah. All right, so this is 5x plus 5. This is 5x. This is 4x minus 6. This is 5x minus 5. This is 4x plus 3. This is 6x minus 12. And this is 2x plus 3. So if I want to find the value of x, then I would just set all of these 5x plus 5 plus 5x plus 4x minus 6 plus 5x minus 5 plus 2x plus 3 plus, why did I skip all the way over there? I don't know. 4x plus 3 plus 6x minus 12 equal to 360. Now, instead of writing all that out like that, I would probably come back over here and just pluck out the x's. So there's 10, 14, you know what I mean? 19, 23, 29, 31. So I would go ahead and start it like that. 31x plus, and then do my numbers. 5 minus 6 is -1, minus 5 is -6. So I would do that, put all my numbers together, and then set that equal to 360. Just a little bit cleaner than writing all those, or write them down and put all your x's together. Either way. All right, I've taken up enough of your time, and so we'll work some problems like this in class. So I will see you soon. This is Coach Lowe, and I'm out.